Okay, so here's a geometric sequence where we haven't been given the start or the ratio, which are the two things that we need to know how it grows. But we have been given some points, so that we don't have to necessarily start at 1. We can start here, and we're using 3 growth factors to get to 625. Okay, so I can write it like this. I can go T3 times R cubed equals T6. Right, that's true because if I multiply this by R 3 times, I get to T6. Okay, so I'm going to go 40 times R cubed equals negative 625, and then I can solve for R cubed. Okay, now remember that I gave you guys a formula. That formula does the same thing. T6 over T3 is equal to R of 6 minus 3. Okay, or R cubed. So we end up with this exact same thing. 625 over 40 is equal to R cubed. So I can solve for R cubed by cube rooting that. I should divide that first. So I'm going to end up with 625 divided by common factor of 5, so 125. So this works out nicely because we end up with perfect cubes in here. So R cubed equals negative 125 over 8. So R is equal to negative 5 over 2. Okay, so this is our common ratio that we need to know. If we want to find out the T1, we could just plug it into our equation like this. We can say that 40 is T3. Maybe I'll write it a little bit more formally. So T3 is equal to 40, which is equal to A, which we're trying to figure out, negative 2 over 5 to the power 3 minus 1. So there's 2 steps from the first term to 40, and then I can work out A. This is going to be 25 over 4 times A equals 40. So I end up with 160 over 25 equals our A value. Okay, and then that simplifies 160. Okay, so we can simplify that to, that's going to be what, divide by 5, so it's going to be 32 over 5 is equal to our A value. Okay, so now we have A and R, we can find the general formula and find the first 5 terms. Now, there's nothing wrong with actually just counting it as well. Okay, this is a sequence. In fact, it's a discrete sequence. So we have 40, blank, blank, and T6 is negative 625. Okay, so we could just count backwards. Okay, so once we have our multiplier, we can move along that sequence by using our multiplier. Okay, so we know that's going to be, so it's going to be negative 620, negative 2.5 is our multiplier. So if I go 40 divided by negative 2.5, I get negative 16 as T2. And then I divide again by negative 2.5. I'm going to get 6.4 as T1. And that's exactly the same as the T1 that I got algebraically. Okay, so there's nothing wrong with actually using that multiplier. So this is going to be negative 100. This is going to be 250. Okay, so this is what our sequence looks like. If we want to use a multiplier to get that, that's perfectly fine. We can use our formulas as well. So here I use the formula to get A. Okay, so the one thing that is about the formula is if you have to take multiple steps, you're going to be much more efficient using a formula. Okay, so my Tn formula in the end looks like this. 6.4, I'm just going to leave it as fraction of 32 over 5. Our multiplier was negative 2.5, which again I'll leave as a fraction, and it's going to be n minus 1. Okay, so there are times where we can just essentially use our ratio to move along our sequence, and that's perfectly fine. That's how it works. We have some formulas that allow us to use some algebra to speed up the process. So if we have multiple steps in between, I can use this formula, right? Tn divided by, Tn plus A over Tn. The difference in those powers gives us the number of times we use the ratio. Okay, so we've been given the first term of geometric sequence is 3. Well, that's the same as T1, and we can use this relationship. We know that T1 plus T3 equals 51, so I'm going to do this. I'm just going to fill in T1 since I already know it. Okay, so then I can work out T3. Okay, so again, what are the things that we need to know? We need to know a starting point. Yeah, there's our starting point, so that's key information. So I'm going to write this down and do this in a different color because this is important. I need to keep track of this. A equals 3. I also need to know the R value. Okay, so I have T3, I have T1. Well, I do know this. I know that T3 divided by T1 is going to be, there's 2 R's in between those two terms. So I know that's equal to R squared. And I know T3 is 48, T1 is 3. So R squared must be equal to 16. That means that R is equal to plus minus 4. So writing down my R is equal to plus minus 4. So knowing those two terms, I'm going to write my general equation. Tn equals A R to the power n minus 1. Okay, so I actually have two solutions here. One is for plus 4, the other one's for minus 4. The question is asking for T10. So T10 is equal to 3, and then the power is, there's 9 steps from 1 to 10, and so there's going to be two solutions. One of them will be positive with a positive 4, one of them will be with a negative 4. So I get 3 times 4 to the power 9. I'm going to end up with positive 78, 64, 32, and negative 78, 64, 32. Okay, so there's my T10, and there's two solutions for T10 because of the plus minus nature of when we're solving for the R value.